Picture this moment. You are standing in the desert, sand beneath your feet, nothing but emptiness around you for miles. Then you look up. A shadow falls across the ground. You turn. And there it is. A tower so impossibly tall that it disappears into the clouds. So tall that the top sways back and forth while you watch. Back and forth. Meters at a time. The building is moving, bending, alive. This is Dubai's newest tower. A building so tall that wind pushes it harder than gravity does. A rainforest growing 500 meters in the sky. Buildings that move and bend like they're alive. Dubai's new towers don't really defy gravity. Gravity always wins. But they do something amazing. They beat the invisible enemy that kills tall buildings, wind. This is how engineers learn to work with nature rather than fight it. 50 years ago, Dubai was just a desert, a small town, 60,000 people, no tall buildings, nothing. Then something happened. Ambition, money, dreams. By 2025, Dubai had 250 skyscrapers, taller buildings than most cities in the world, in just 50 years. Engineers had to learn how to build from scratch, no one to copy from. They had to figure it out themselves. The Burj Khalifa was completed in 2010, the world's tallest building at that time, 830 meters high. But the engineers faced a terrifying problem. At 400 meters high, something catastrophic happens. Wind becomes stronger than gravity. A tall building weighs millions of tons. Gravity pulls it down. That's manageable. But wind pushes sideways. Not just once, all the time, with a force as strong as the whole building's weight. If the building stands stiff and rigid, it fights the wind. The pressure builds up. The building shakes. The shaking gets bigger and bigger. Eventually, the building breaks. This is how tall buildings die, not from gravity, from wind. The engineers at Burj Khalifa had a brilliant idea. Instead of a straight building, make it shaped like a Y. Add twists and steps as it goes up. These shapes confuse the wind. The wind can't form organized patterns. It gets disrupted. The building stays safe. This was the first innovation. Shape the building so wind loses control. But the real genius was completely different. Instead of fighting the wind, work with it. Inside modern towers, a tuned mass damper sits. Imagine a 600-ton concrete block suspended on springs and hydraulics inside the building. When wind pushes the building sideways, the damper resists, moving in the opposite direction. They cancel each other out, like a shock absorber in a car. The building barely moves. This was the second innovation. Passive response to wind pressure. Then came active intelligence. Steel cables run from the center of the building to the edges. When the wind pushes, these cables distribute the force across the entire structure. No single point breaks. But the coolest part is the sensors. Thousands of them. They feel even tiny movements. Computers make thousands of tiny adjustments every second. The building isn't just strong, it's intelligent. It feels danger coming and adjusts before the wind even hits. This was the third innovation. Active response through technology. Buildings became responsive systems, not rigid monuments, living structures that breathe with pressure, respond to danger, and adapt to forces. Burj Khalifa proved that shape matters. Dampers prove that passive systems work. Sensors prove that intelligence changes everything. Now consider Burj Azizi, 725 meters, second tallest building on Earth, finished in 2028. At that height, the wind is constant, over 100 miles per hour, all day, all night. The building has to flex, move, respond, advanced cores, multiple dampers, tapering shape. Everything is designed to work with the wind, not against it. The engineers tested thousands of scenarios. They studied wind patterns from around the world. They learned how wind behaves at extreme heights. They discovered that what kills buildings isn't the wind itself. It's the building's resistance to the wind. When the building resists, the wind gets stronger. But when the building bends and moves with the wind, the danger disappears. But new challenges arise. Some towers hide their engineering inside. Symphony Tower does the opposite. The entire skeleton is on the outside. Diagonal steel beams crossing everywhere. Like a beautiful pattern. Why diagonal? Because diagonal beams are stronger. They resist forces from multiple directions at once. Lighter, stronger, beautiful. This is engineering as RT. Then came Tiger Sky Tower. 532 meters tall. With a rainforest on top. An entire ecosystem floating 500 meters high where the wind is violent. Where the ground is constantly moving. Where nothing in nature should survive. Engineers had to invent everything new. How to anchor roots in soil that moves. How to transport water through a swaying structure. How to keep soil in place while the building bends. How to create wind barriers that don't stop airflow. How to allow plants to photosynthesize in extreme conditions. They didn't just build a tower. They built an alive structure, an entire rainforest ecosystem swaying in the sky, roots gripping, leaves moving, life thriving where life shouldn't exist. This was the revelation. When you understand forces completely, you can create life where it was impossible. Now picture Frank Muller Eternatus Tower. 450 meters tall, with a massive clock. A clock that is precise, exact, never changes. The building underneath is responsive. With it rather than against it. When they create responsive systems, when they integrate nature itself into their structures, even the tallest building becomes stable. Even a rainforest can grow 500 meters in the sky. This is the real story of Dubai's towers. Not defying gravity. Mastering the invisible forces that act on tall structures. Not conquering nature, cooperating with it. Not rigid monuments. Living systems that respond, adapt, and thrive. Drop a comment. What seems impossible in your field that could become possible with a deeper understanding of the forces acting against it? And subscribe. Because the next investigation explores how this principle understanding forces instead of fighting them is reshaping everything from infrastructure to technology to how humans build the future.